welcome back. I hope you had good lunch. Okay, can we start now? Pranay, Jagan, are you there? Okay,
Okay,
welcome back.
welcome back.
I think
I
you
think
had
you had
good lunch
good lunch,
and
and we
we
are
are
possibly
now we can
now we
resume
can
back. We
resume
can
back.
start,
We can
right?
start,
Pranay,
right,
Jagan?
Pranay Jagan?
Yes, Mangesh, yeah, I'm back. Hello?
Hello.
Ah,
Ah,
Jagan, we
Jagan,
can
wait,
resume,
we
right?
can resume, right?
Yes, yes,
Yes,
yes.
yes.
How about you,
How
Pranay?
about you, Pranay?
And I hope
And I
I'm
hope
loud and
I'm
clear,
loud and clear,
audible to
audible
both of you.
to both of you.
Yes.
Yes,
Yes,
yes.
yes.
Pranay, I'm not
Pranay,
able
I'm not
to
able
hear
to
you.
hear you.
Pranay, are you there?
Pranay, are you there?
Yes, yes, sir, I can hear you.
Okay.
Okay, okay, good.
Okay.
Okay.
So far
So
we
far
have
we have
completed the last
completed the
session of
last
the
session
risk
of the risk
assessment and
assessment and
analysis,
analysis,
safety
safety
management,
management, and threat
and error
and error
management.
management.
So we
So
are
we
on the
are
10th
on the
module
10th
of today's.
module of
So
today's.
we have
So we have two modules,
two
actually
modules
two
left.
modules left.
Okay.
Okay.
Last one is
Last
digital
one is
skies.
digital
That is
skies
supposed to
introduction
be
that
done
is
on the
supposed to
third
be done
day
on the
or
third day or
maybe
maybe
during
during
the practical
the
session.
practical
But
session.
we'll
But
still
we'll
touch
still
base
touch
on
base
those
on those
portal again
portal
today
again
as
today
we
as we
initially
initially
also
also
did
did
at the start of
at
the
the start
session
of the
yesterday.
session yesterday.
So we'll again
We
run
will
through
again
the
run
digital
through the
sky
digital
portal.
sky
I
portal.
will
I will
show
show
you
you
where
where
what
what
is
is
what,
what,
and
and
you'll able to
you'll able to
do things on
do
it.
things on it.
So let's
So
start with
let's start
payload
with payload
installation and
installation and
utilization.
utilization.
So what kind
So
of
what kind of
payloads now as
payloads
we
now,
know
as we
the
know,
drone
the drone
what
what
is intended.
is
It just
intent. It just
you
you
just
just
don't
don't
need
need
to
to
fly
fly
it
it for on its
for
own
no
for
other
no
purpose,
other
but
purpose, but
some other
some other
applications needs to
applications
be
needs to
used
be used
through
through
the
the
drone. It
drone.
could be
It
for
could be for
agriculture, for
agriculture,
spraying,
for
seeding,
spraying, seeding,
or
on
monitoring the
monitoring the crops, monitoring
soil,
the soil,
and various
and
aspects
various
of the
aspects of the
agriculture. Or
agriculture.
if you have
Or
an
if you have an
inspection or
inspection or
surveillance drone,
surveillance drone,
you will
you will
intend to use it
intend to
and
use
fly
it
it
and
for
fly
the
it
purpose
for
of
the purpose of
surveillance. It could be
surveillance. It
road,
could be road,
rail,
rail,
dams,
dams,
or any
or any
infrastructure.
infrastructure.
It could be
It
a
could be
building,
a building, it could be
tower,
a
it could be
tower,
a
it could
windmill,
be a
anything,
windmill, anything,
whatever the
whatever
projects
the
you have,
projects
power
you have,
line
power
towers,
line
all those
towers,
things
all those things
we can
we
use,
can
or even
use, or
simply
even
for
simply
crowd
for crowd
monitoring
monitoring
purposes, or
purposes, or
monitoring,
monitoring,
or maybe
or
for the
maybe
supply
for the
chain
supply
with
chain
respect
with
to the
respect to the
delivery of
delivery
medical
of
supplies
medical
or
supplies
food
or
or
food
any
or
other
any
supply
other supply
as per the
as per the
requirement.
requirement. Okay.
So let's see
So
what are
let's see
the
what are the
payloads are
payloads are
available.
available.
You
So
see, this
you
is
see, this
more or
is
less
more
like
or less like a
DJI
DJI
Phantom
Phantom
drone,
drone.
okay, where
Okay,
we have
where we have
visible light,
visible light
optoelectronics
optoelectronics
payload
payload available
available,
over there.
night vision
Night vision
optoelectronics payload,
optoelectronics payload.
even the first
Even
aid
the
kit,
first aid kit.
okay,
Okay, remote control loudspeaker can be also connected.
remote control
Remote control
searchlight.
searchlight is also.
So there are
So there are
some
some
payloads which
payloads
were
which were
used
used
uh,
uh,
during even
during
our
even
COVID
our COVID
times,
times,
like for
when,
example,
like for
first aid
example,
kit
first
was
aid kit
supposed to
was
deliver,
supposed to be
medical
delivered,
supplies
medical
to be
supplies
delivered,
to be delivered,
or
or
sometimes the
sometimes
crowd
the
monitor
crowd monitor,
police has
police
used
has
during
used during
the crowd
the crowd
management,
management,
the
the
loudspeaker, so that they
loudspeaker,
can
so
able
that
to
they can able to
communicate to the
communicate
people
to the people
to
to
stay indoors
stay
or not
indoors
to
or not
form
to form
a big
a
group
big
and all
group
that
and
thing,
all
or
that thing,
even
or
remote
even
control
remote control
searchlights
searchlights
when
when
they
they
want to
want to
search,
search,
especially
especially
in
in
wildlife
wildlife
monitoring
monitoring
or
or
some
even some remote
remote
areas
areas
where
where there is a
there
challenge.
is a challenge.
You can use
You
those
can use those
searchlights,
searchlight,
and then
and
high-end
then high-end
36
36 zoom HD cameras can be connected, or infrared thermal imager also can be. So let's see what are the basic payloads, types of payloads, and payload applications with respect to the drones. Okay. So payload, the most important definition. Payload is the weight a drone or a remotely piloted vehicle can carry or unmanned aerial vehicle can carry. That means whatever additional apart from the drone. See, when there is a drone without a payload, it's just like a vehicle. Okay, it's like just an instrument, but it will give value only when there is something payload, something it is useful for functioning. Okay, so payload is the weight a drone or a remote piloted vehicle can carry or unmanned aerial can carry. Any of these, okay, either of irrespective of what it is. It is usually counted outside of the weight of the drone itself. So when there is no payload, we call it as a normal weight of a drone. Okay, and includes anything additional to the drone such as extra cameras, sensors, or package for delivery. Then it becomes a payload. Like on an agriculture drone, only drone would be something which would be like somewhere around 12 kg or 15 kg max. But when I attached my tank, fertilizer tank, then that is something like a payload. And I am configuring that drone as an agriculture drone. Along with the tank and the motor, pump motor would be there. So these two things would become a payload for that particular drone. So payload is the weight a drone or remotely piloted vehicle can carry. It is usually counted outside the weight of the drone. So when you are considering the drone weight, it is just a normal weight excluding the payload capacity. Okay, so a lot of time even the bigger drones, larger drones like predator drones, or they might be a drone which is having a huge capacity to carry the payloads. Like it could carry a missile, it could carry a sensors, it could carry a devices. A lot of things it could be carry on its fuselage. Okay, connect to the fuselage or even to the wings. Okay, so physics of the payload. Like you can't just simply put something below the drone and it will impact the overall dynamics of the. So it might be all seems bit obvious, but here goes the higher the power to weight ratio your drone has, the greater the payload it can carry. That means what? Yesterday I told you, like if I am designing a drone, okay, I intend to make a drone for carrying a weight of, let's say, maximum weight would be let's say 25 kg. So when I am designing a motors, all four motors should contribute and it should have a capacity to pick up the weight, or uh, what do you say, carry the weight at least twice. So if I'm designing for a weight of 24 kg or 25 kg, I will multiply by 2 and I will design a drone in such a way that has a capacity of 50 kg. However, drones with higher power to weight ratios are all those couldn't carry 10 feet because they will become more and more heavier. So that is where people lose the concept. Like if you design it, let's say one motor is having a capacity of, let's say, 8 kilogram. Okay, so if you are in 8 kilogram, or let's say less than that, say let's 6 kilogram. If I have one motor of 6 kilogram power to weight ratio kind of thing, so if I put those four motors, what will happen? So 4 into 6, it will be having a capacity of, all total 4 motors working at the same time, it will have a capacity of 24 kg. But can I put a 24 kg on that drone? If I put that, will it rise?
No, sir.
Why?
Because capacity of 6 kg only, no?
9. If you see 6 kg is individually motor, multiply by 4,
Okay.
multiply by 4, 4 motors I am connecting. So what will be the total cumulative weightage capacity?
24.
24. But if I put a 24 kg weight on it, okay, now drone itself weight will not be 24 kg. It has a capacity of 24 kg. Now I put a weight on it. Let's say I put 24 kg total. I mean, including drone plus, let's say my drone is weighing only let's say 2 kg or 4 kg. Assume it is just weighing 4 kg along with the battery and everything. Assume it is 4 kg. So my capacity of drone is 24 kg. Now I can add a weight up to 20 kg.
Yeah.
If I put a weight of 20 kg, will it rise or not?
It will be its maximum weight, right?
Yes.
Maximum that it can able to carry 20 kgs.
No. See, again understand one thing. You have four motors which has capacity of 6 kg. So your motor can pick in all total weight is 24 kg. Now my drone weight is only 4 kg. So I have still deficit of 20 kg. Correct? If I don't put any weight, let's assume, forget about the weight. Assume that my drone is weighing only 4 kg. My motors are 6 into 4, that is 24 kg capacity. I start flying it. Will it fly?
Without
No,
payload.
sir.
Without,
With payload, na?
without payload. I'm talking, as of now, I'm talking only without payload. My drone weight is 4 kg. My each motor has a capacity to pick up 6 kg.
You
I
can
have 4 motors. I have 4 motors. So what will happen? Whether my drone will fly or not fly?
it will fly.
Fly.
It will fly because I'm just having weight of 4 kg. Okay, my drone will fly. Let's assume that I add 10 kg to it. So what will be my total weight of my drone?
14.
14 kg. Now if I fly that drone, whether it will fly?
Yes, it will fly.
It will fly. Now if I add another 10 kg to it, what will be my total weight of my drone?
24 kgs.
24 kg.
Fly.
It will struggle to fly.
Yes, it may struggle or it will fly also because it's still having that capacity. It will, with great difficulty, it will try. You will not get optimal, will struggle to rise because every time that weight will pull it down because that is what maximum it can pull. If I add another 2 kg or 5 kg also, it will not fly because it has to generate that much thrust. It has to act. It may not really fly. It will just keep on rotating, but because it will not able to counter that, let's say 29 kg or something or 30 kg, it will not able to fly. Okay, so that's what I'm saying. When it is reaching 24 kg, it is reaching the maximum what it can pull. But the optimal performance of the drone you required, whatever the weight is defined for that particular drone, you need to always consider half. That means if you are having a motor of 6 kg capacity and you are having 4 the 24, 24 ka half is 12. So the weight of your total drone along with the payload should not exceed 12 kg. I hope you understood what I'm trying to tell you here.
Yes, yes, yeah.
Yes, sir.
So yours should not. So to give a better quality, so you always consider 50% of your capacity of your drone's performance or carrying capacity, I would say. So when we are designing a drone or when we have a drone which says the maximum all of weight is 24 kg, means they have considered it only 50%. I can put even 16-liter tank to that. It may extend the weight from 24 kg to let's say 30 kg also. That drone will fly, but it will not give me the optimal performance. Okay, it will have to because 50% is what is normally it is 60%, but standard practice what we see is 50% people consider. So we can't have more than 24.90 weight on that particular drone. Similarly, if I have designed a drone for 20 kg, my maximum carry-on capacity would be 10 kg. If I have designed a drone for let's say 30 kg, my maximum capacity for that drone would be 15 kg. So you always consider half. Okay. So that's why it's saying heavier the drone will have some impact on power required to carry the big payloads, and you will see this pay off in flight duration possibility also. So when you are saying you have a 20% of 20 minutes of flight time, that means that point in time they're considering 50% of weight capacity and that optimal. If you increase the weight beyond 50%, it will impact your flight duration also. You may not able to fly the drone for 20 minutes. You may fly it only for 15 minutes or something like that. Okay. You could always consider upgrading the battery by adding the battery you can increase the endurance, but bigger the battery. Let's say you have 5000 mAh, you add 10,000 mAh battery. So it is almost like a double the size of the battery. So automatically your battery might be weighing, let's say, 800 grams. You are adding another 800 grams to that payload. So your drone, which was initially having a weight of 4 kg, it will become a 5 kg drone. So again, you are reducing the weight of the payload. You can't use 20 kg. You will have to reduce it to less than that. Okay, so that's see every time you try to add plus minus, you will have a challenges. Okay, so it all about the lift. You can have two drones of the same mass, one with larger rotors, one with smaller rotors. The one with the larger rotor will create more air thrust with the same power despite the air flow being slower than that be generated by the smaller rotor drone. That means if you have a smaller FPV drones, if you see FPV drones, they rotate very fast. Okay, the propellers are very running very fast. So they may you might feel they are very high powered or high capacity, but they are because they are very light. That's why you feel that. But the bigger drones like agriculture drones, you see their propellers are very big and their propellers are not running very fast compared to FPVs. But still, it is able to pull up the large weight compared to the small drones. Okay, so despite airflow being slower than the generated by the smaller rotor drones, you still see the larger drones are able to pick because their propellers are very big. Like my propeller on the agripod would be around 18 inch or 19 inch. Okay, even if there are drones which is having 24-inch propellers, or even some drones I have seen 36-inch size of propellers. So the more the bigger the propeller, the more thrust ratio it will have to generate. Okay. The gimbal, as we learned earlier, gimbal are used to stabilize the camera payload that have been mounted on the drones and other autonomous vehicles such as UGVs, underground vehicles, okay, underwater kind of thing. So gimbal integrates an IMU, inertial measurement unit, to respond to motion and provides inputs to controller that activates separate motors. So there are two motors, right? Their gimbal could be 2 axis, 3 axis kind of thing. Okay, so in the more number of motors you have, more control you have on the angle what it is doing. So there are at least you need to have a 2 axis. Okay, so control the activity separate motors to keep the payload in a steady on each axis. Types of electro-optic payload. So different types of optical payloads you have. RGB camera is there, thermal camera is there, lidar is there, or multispectral cameras are. So different has different options. The cheapest one is the RGB cameras, but from a perspective of what actually you are looking to capture, like normally you will see a Sony camera will attach as a RGB camera which has a capacity of 20x optical zoom and 20 megapixels or sometimes even 50 megapixels of cameras are there. Okay, then you have a thermal camera which are very expensive. Again, it range between 2 lakhs rupees to 6 to 8 lakh rupees. Even lidars are in that range. I think lidar are somewhere around 8 lakhs, 10 lakhs, 12 lakhs, 15 lakhs, depending upon what kind of lidar it is and what purpose the lidar it is, how big is the lidar. Even the multispectral cameras, what we use for analyzing the location or mapping or survey or even in the crop monitoring kind of locations applications, we use multispectral cameras or even hyperspectral cameras. What we use, they are range somewhere around 4 lakh rupees to 10, 20 lakh rupees of cameras are also available. Okay. So what does RGB camera does? Okay, it's nothing but it's like a human eye is sensitive to red, green, and blue bands of light. Most of the standard drones comes with a camera that captures the same RGB band, so the image they produce recreate almost exactly what our eye sees. So it is a normal whatever even mobile what we have the camera, same cameras are there, but they are more optically they are more efficient. Optically, the sensor wise also they are more. Uh, High end which will able to capture the light properly in a proper manner so that you will able to see what actually you are supposed to see when you are looking to that particular object what it is been captured. So what does the drone RGB means? An RGB camera on your drone can see your entire field in one place by processing aerial image into an orthomasic maps. Quickly make observation, enter the geodata into GPS, drive the rights in the problem area without damaging your entire field. So see, it will capture the data. Okay, the RGB will capture the data in a different angles and pictures and all those things. But whatever data you see on the screen, it will be not available immediately to that. There are separate softwares required. There are multiple softwares are required to convert that data into, like, orthomorphic maps or three-dimensional maps. All those things, whatever you do, there is a separate software. So you feed that data into all those images into that software, and then you create that structure. You create those different types of maps required for your analysis purpose, or for any customer or any vendor, anybody who has requested to carry out this kind of activity. You need to have those software. So like the QGIS software is there, or not Pixel, what is it called? Forgot the name. I have a slide we'll talk about. So what is an RGB camera? RGB is again a visible camera sensor, collect visible light in 400 to 700 nanometers and converts that into electrical signal, organize that information to render images and video streams. So you see your image, what you see, it will be in a very raw format. There will be a separate software which will make that software, those images to be in a useful format or for analysis perspective. Like if you see on the picture, there is a mineralization, seed rate, soil organic matter, denitrification zone. I mean, these are the images what will be converted using the softwares. Okay, photomagic softwares are there. The features of the payloads. Now, when you are using the payload, like you can even capture not only photographs, but you can make it from the videos also. Then object tracking also there. But these are the softwares needs to be. These are additional softwares which would be required. Like let's say I was seeing one of the drone where it was able to chase a car. So first of all, that camera and the software which is running on the drone, there is a separate unit for it, which keeps on tracking the particular device and gives the signals to the drone, and it keeps on tracking the drone. And like for example, there was a chase happening between the car, and the police was using the drone for chasing them. Earlier, people used to follow the car normally on the road, but now even drones are used to track or chase the particular car or particular criminal locations and all criminal uh, vehicles and all that thing. So they have that facility of AI driven cameras, which will actually identify the number plate, identify the car, and it will keep on tracking as the object is moving. Okay. So like again, you see different. It is able to read, tell from the RGB sensors. If you have you configured it for reading the images. You have trained the image, so it will tell you which one is car, which one is not car. Like for example, if you see this on the right side, the tempo it is not able to detect, but it is detecting as a car, but it is only showing 89% accurate as a car. Okay, whereas if you see a small car, this is 99%, this is 99%, this is 99%. Okay, even I don't know why the bus it is showing as car as a 99%. So that's what I was talking about. Sometimes you might get a false report also, because it is not that still accurate, still 100% sure that it will accurately identify between tomato and apple. Okay, because of the lights, the way it interprets the images, and way we have trained that software. The capacity what as a human we can interpret. I saw one image on the internet. Okay, there was one dog sitting at the gate, and there was a gate with the rods. Okay, and because of the sunlight following uh, on the dog, but that light was obstructed by the bars of the gate. So there was on the dog's body, the dog was white color dog, and on that dog's body, those sunlight was falling, and because of those bars on those gate was creating the stripes. So when the photograph was taken using an AI camera, AI camera told that it is not a dog but it is a zebra, because whatever those images what was created on the dog's body, because of those strips, it was like a zebra crossing markings on it. So they saw that it is a zebra kind of thing. Let me see if I have that picture. I saw somewhere. I thought I. Let me figure it out. I'll share it to you on WhatsApp. Okay. So that is what I'm saying. So though we have such a technology, but still that technology has not evolved to that extent where you have 100% accurate results or 100% accurate. Like if you see on the left side the crowd traffic monitoring what we do in this such a huge traffic, to identify all the people who are sitting there and all that, it's become difficult because we do not know. The camera maybe not see, he will try, if you give him one particular face, it will try to locate in this particular entire thing. It will try to see if there is a matching face to that face. But then see the amount of data and see the amount of data. It is so cluttered, okay, so crowded it would be. In that, your image is not so clear. You do not have a right or clear image of each face. So in that, it is very difficult to find a particular face. So that still it's not so evolved, so accurate. So the kind of RGB cameras what you use, what kind of megapixel amount of data it captures, how much optical zoom it can take, and all that lot of things factors comes into the picture to get a right image and right amount of data to analyze at a later stage. Okay. In disaster management, drone can be used for fire detection, intervention monitoring, and also for post-fire monitoring also. At border security also, drone can be quickly fly over the detect threats and provide aerial images in real-time footage. So you rather you going towards the border area and sending military guys or army over there to monitor and you can always fly a drone and keep on monitoring your border remotely, every time, like every 15 minutes or every 30 minutes or every hour, you can always uh, fly your drone and you can keep on monitoring the borders areas. Similarly, for a disaster, also you can, in especially in the forest area, you want to monitor because a lot of time you will only know the fire in the forest when it goes very big, okay, or somebody detects it, then only you will able to know. Or lot of time the small fire starts and then it will catch up and it will extend such a big way that it's become very difficult to manage. So if you have a drone, you can always fly a drone and just keep on monitoring those locations also, so that you can prevent the big fires in the forest or something, all those locations. Okay, so application of RGB sensor, again aerial surveillance, the use of unmanned and increasingly completely automated drone inspection has already caused huge waves in the asset management sector. Like for example, this aerial surveillance right now currently is in very much is used at Kumbh Mela. You have seen lot of drones are being flown over there by IG drones company, and they are giving the footage to the government or the authorities, so that you are able to keep the control on the crowd and tab on the any untoward issues happening during such a huge gathering of the people over there. Okay, so application of RGB sensors, you can use it for solar farm, wind farms, railways, bridge inspection, power lines, mobile phone towers, oil and gas inspection, water pipes, building and construction. So we had done one small POC for Reliance. They have a refinery in Jamnagar. So all those oil and gas pipelines which flows from the refinery to X location, they have asked us to fly the drone and provide us the data about the pipelines which are laid on a regular basis. Okay, so it was almost like 20-25 kilometers of area which needs to be covered, which was external. I mean, most of the time these pipelines are underground or they are within the ground. But there were some places where they were above the ground, so they wanted us to see if the drones can be useful to monitor these kind of installations, oil and gas pipelines. Okay, a lot of times you will see these oil and gas pipelines are also going through very remote, dense forest kind of areas also. Even water pipes, like water, like Mumbai is supplied a water from Vaitarna or Tansa, those lakes. Okay, so the distance what it covers from those lakes till Mumbai filtration plant is very huge. So a lot of time we have seen the water is been the people break the pipes or make a small hole in the pipes, and you will always see a lot of leakages of water and loss of water and all things. So you need to keep on monitoring these pipelines on regular basis. So visiting every time these pipelines is very difficult. Sometimes they are running through a very, I would say, very densely forest areas, or it is very difficult to every time to reach such places also. So drone has been very useful to monitor such kind of installations or such kind of infrastructures. Of course, solar farms, wind farms, railway bridges or railway tracks, bridges inspection, or even railroads. Okay, all those locations, power lines. I have given example of power lines, mobile phone towers, and even in buildings and construction. In real estate, drone has taken up a lot of place where people are started using to see the progress of their buildings and construction happening at their different sites. So they will ask some vendor to fly the drone on a regular basis, like every month you visit first week and submit me the report of the progress what has been done on the building or the construction site. So like this, that will you really don't need to go every time to see the progress, and you will also have a record or you will have a footage of your progress, so that accordingly you can update to your customers or to your financial institutions from where you would have taken a loan to show the progress of your project or show the progress of your construction line. Okay. So again, application of RGB sensors primarily in mapping. It could be 2D mapping or 3D mapping. In 2D mapping, you can do only 2D mapping because you have a fixed camera. If you want to do a 3D mapping, because you have to take it from a different angles, you need a camera with a gimbal. Okay. Then again, mining, erosion detection, boundary management, project progress monitoring. What I told you about in the civil line or in the construction line, normally for showing the progress of your project and monitoring purpose, you will use RGB sensors or RGB cameras. Thermal camera. Now, thermal cameras mostly like we have seen it in monitoring your power lines, telecom towers, or even your solar panels, wind farms. These are the locations where the thermal cameras are being effectively used to detect a lot of things what a normal eye or a normal camera is unable to detect. So thermal camera detects infrared light invisible to human eye. Thermal image, also known as thermal camera, is essential as a heat sensor that is capable of detecting any tiny differences in temperature. Because if sometimes the wind blades or even the power line towers or telecom towers, their what is that metal has become corrosive or wires have become corrosive. All those things are not visible to your naked eye. So in a thermal images, you are able to detect these differences in the temperature, because definitely the different part of your material will give you the different heat sense. So that these thermal cameras will collect the infrared radiation from the object in the scene and creates an electronic image based on the information from the temperature difference. So once you know those temperature and you will able to read the thermal inputs, you will able to tell whether there is a problem in that particular material or that particular image, and accordingly you can take the corrective actions. So application of thermal payload originally developed for surveillance and military operation. Thermal cameras right now are widely used in building inspection, like moisture. Like for example, there might be a leakage in your building. You will not able to see, or you will not able to track from where the leakage is happening. You might see on the wall has become wet and all that, but you want to find out the source from where the water. So you can always use the thermal cameras to detect, because the leakage will be colder part and the remaining part will. So you can really track, you can find out the source of the leakage, or from where the actually leakage, or how the water is flowing inside the walls, by seeing the temperature difference in the wall and the beams and all that thing. Okay. Again, in firefighting, autonomous vehicle, automatic braking, skin temperature, industrial inspections, solar panel inspection, power line inspection, pipeline inspection, wildlife monitoring. So even lot of time from the outside, the pipe might look good, but the pipe might have gone bad, maybe rusted within the material. Just because of the stress, the material might have got very weak. Okay, and it might be a possibility that the water pipeline may some other day might break. Okay, it might get into the leakage situation kind of thing. So rather waiting for that reactive situation, we can always run a thermal payload and capture the images and see how the structure of the pipe is there. And based on that, we can take a call whether it needs some repair, or some meditation is to be done, so that major fault or major loss of infrastructure or resources are not happening. Even in the wildlife monitoring also, like lot of time, like these tigers or elephants, or even very rare species, what are there, lions, all those can be monitored using the thermal camera. You can see the picture of the building over here based on, so moisture, insulation, roofing, what you can see. Okay. In firefighting also, you see when there is a fire, the building is completely red in color, red and yellow color. Okay. Whereas the people are there, they are also being, as they are having a body temperature, they are also shown red. Whereas the ground, you can see it is in a blue or violet color. So because it is a cold part. Okay, even you see the pipe is, it is showing in a blue color, because there is a water, that is a hose pipe. Okay, so that's why it is showing in blue color. Okay, also in autonomous vehicle, automatic braking kind of thing. So you will able to, you see the images in infrared. Okay, how it looks and all. So there is a huge, I would say, a study going into this. This is something what we call as image study or GIS study kind of thing, where the RGB, thermal, lidar, all these things are taken, and you try to train the software, or try to interpret the data based on the different, like you may have a same image in RGB, you can take the same image in infrared, you can take the same image in lidar, and then try to correlate and try to understand as much as possible what could be the anomaly into that particular image, and then you train your software accordingly, so that you every time you don't need to do manually finding of the faults or finding the issues. Like here, you can see the skin temperature. Okay. So without actually, this was very much in use during the COVID times, where people used to want to monitor the temperature of person, if there is he is having fever or not fever and all that. So without touching him, without getting in contact with him, remotely only, just flying a drone over the people, you are able to take the temperature of the people as required. Again, in industrial inspections, thermal is very much after RGP. Thermal is very much used into the construction sites, or even into the uh, infrastructure related projects, be it windmill, be it power lines, be it gas and pipelines, water lines, or even into the industrial inspections, like big manufacturing plants or refineries. All those locations, thermal payloads are being, the thermal cameras are being used extensively, so that you really don't need to monitor or go physically all the locations. Your camera, your drone with the thermal camera is able to take the complete footage, and then you can sit down and you can analyze all your footages, all your images, and accordingly you can make a report. Like as I said, building inspection, then solar inspection, power line inspection. Then comes the LiDAR sensor technology. In LiDAR sensor technology, it is nothing but light detection and ranging, because a lot of time your RGB, because of the light, because of the thermal not able to reach the ground. Let's say there is a crop, okay, you can't see below the crop, or there is a tree, you can't see below the tree. So in that scenario, you will always use LiDAR as a LiDAR sensor to capture the images. Okay, so it is nothing but it's a light detection and ranging. Use light energy emitted from a laser to scan the ground and measure the variable distances. So using those signals, it try to create the image out of it. Okay. So this is something a reverse way you are doing it. So LiDAR, which stands for light detection and ranging, is a remote sensing technology. Earlier, this was primarily used into the satellites. This was done through the satellites, or even on the survey. People who used to do put the LiDAR on a car, and they used to survey the locations and all that. But now this LiDAR earlier also was not so much available into the drone as a payload. But recently, there is a lot of development has happened into the LiDAR sensors. They have become little bit cheaper also compared to what earlier the LiDAR was available. So that can be used on to your drones as a payload, and you can start mapping the surface and acquire the meteorological data. So lot of weather, lot of geographical or geological people have started using LiDAR on drone, and then they started capturing whatever the surface or whatever the data they required for, could be a meteorological data, or could be a geological data, or could be data used for study of different types of uh, applications. It could be agriculture, it could be forest, it could be water resources, it could be any kind of resources which is useful for a human life to sustain over the location. Okay, can be seen. Like if you see here on the right side, agriculture and forest. Use LiDAR to inspect vegetation such as leaves and crop. Also above the ground, for example, forest canopy can be removed to view the ground surface area. Because all the unwanted, like as I said, give an example of the power lines. After the rainy season, you will see all the power line towers, whatever we have, they will always have lot of vegetations around the power line towers. Okay, which will actually make it difficult for to go near to the tower to see whether things are proper or not. So every time you there is a LiDAR been flown, LiDAR will capture that so much vegetation has grown. That report would be sent to the power line body, and then body will take a decision, and they will give order, or put up a tender to remove all those vegetations or cut that grass near power line towers on regular basis. Okay. Application of drones, mostly like agriculture drones, can help farmers to optimize the use of inputs, seed, fertilizer, water, to react more quickly to threats, even the weeds, pests, fungi, to save the time crops counting, validate the treatment action taken to improve variable rate prescription in real time, and estimate yield from a field. So even not only from spraying or seeding, the drone can be used, but drone can be also used for monitoring the crops, monitoring the soil, monitoring any challenges or any threats you have. There could be unwanted weeds are growing, unwanted pests are affecting your crop, or unnecessary fungi is growing. So rather, see, you can't go each and every plant, each and every part of a crop to see whether what is the problem. But if you fly a drone on it, and it will capture the entire area, and it will give you the data on your laptop or a tablet, and you will able to see as per the farm, the area what you have, you will able to find out what problem does it have, which area of problem. So it may be your small part of your farm would have been impacted by a pest or some threat. It could be fungi, or it could be weeds, or anything. So you can immediately, before it grows to entire farm, you can take a corrective action in a very short time. So that's the advantage of the drone, so that it will give a full complete view of your farm on your tablet, even on the mobile, or even on your laptop, so that you can take a corrective action. You can take a timely corrective actions. Okay. We talk about the application of drones also for advertisement or media publicity and all the things. So you can use multiple or a swan drone technology where you can fly a drone and create a lot of good images in the sky as a light shows or advertisement shows. Okay. Just the last application. Do you have any questions on the payloads?
Yes, sir. I
Yeah.
have.
Yeah. Tell me.
मला हे विचारायचं आहे की आपण ज्यावेळेस प्रॅक्टिकल करणार आहोत तर त्यावेळेस आम्हाला हे सगळे पेलोड बघायला मिळतील किंवा वापरायला मिळतील का?
Nine. There is no practical based on the payload because see, we are not here. The course is not designed for any usage of the payload. The course is designed for flying the drone.
ओनली फ्लाइंग द ड्रोन.
Only flying the drone, how to fly the drone and how you are doing. So you are becoming a pilot. You are not become a specialist. Like if you want to become a like a agricultural pilot, or you want to become a surveillance pilot, or you want to become a some some specific use case of the product. That is a different. There would be a separate course or different course would be there. Like even in a case like your aerial photography or videography, what you do, that itself is a different course in itself. Okay, whereas this DGCA, whatever this course is been designed, is more or less from a perspective of your flying skills. Got it?
ओके.
There are
मग
there are organization, there are people like we are also working with one of the person who is actually into a cinematography. Okay, so we are in discussion with him. So we said that as we have got the authorization, we wanted to start a course for a people, a 2 day course for a people who can come and do the aerial photography, videography, and then they will be that so that one day or 2 days you will fly the drone, you will capture the images, you will capture the videos, and 2 days it will be like offline where you will process the images, process the videos, and all the things, and then that's how you will learn not only the flying part of the drone, but not actually the flying, but capturing the image. How do you capture the image? How do you really fly drone from a perspective of videography or photography perspective, and then you transfer that images on your laptop, and then you process them so that it becomes very much useful for the end user or the person who has given you the order. You can process it.
आणि मी काय म्हणतोय मला जर हे शिकायचं असेल म्हणजे लायडार त्यानंतर थर्मल इमेजिंग
Hmm.
आणि आणि अजून काय तर
RGB है, लाइडर है और थर्मल है, फिर
आरजी
स्पेक्ट्रल है, देन
आपली
स्पेक्ट्रल है. RGB means
आरजीबी
normal.
नॉर्मल आपण मी पण जे करतोय ते आरजीबी मध्येच येत आहे.
Yeah,
ओके.
that's yeah.
तर तो पार्ट वेगळा पण मला जर हे स्पेशलायझेशन करायचं असेल त्यात तर त्यासाठी मला काय करावं लागेल?
So I really don't know who actually teaches this kind of activities, but for example, let me tell you, I am doing my PhD, okay, in Pune Symbiosis University, okay, where my subject is basically geoinformatics. Okay, so in that I have taken a research area where you can fly the drone using RGB, then your thermal and multispectral, hyperspectral kind of payloads, and then do the research on it. But I do not see any vendor who is providing. There are vendors who are providing services. They are providing services, but there is no what we say course been run by any organization as of now, apart from if until unless you do MSc in geoinformatics or MSc in remote sensing kind of activities where you will able to learn this kind of usage of this technology, and then after usage of this technology how to do the post processing and all the things. So as of now, I don't see anybody. There might be someone, but still I'm not encountered anybody who could teach you as of now. I mean, nobody is doing a course where they will allow you to fly a thermal camera drone, and then they will teach you how to use and do it. So there are people who are already learned it in their academic part, and then they have joined some organizations, or those people who are into this kind of activities. For the experience, only people have learned doing this. So this is also one of the area. Like, how did you learn aerial photography or video? On your own, right? Similarly, there are
Yes,
people
yes.
who have learned on their own only, but there is no as such course. So ideally, apart from, I would say, Pranay, what I would say is, you should also think, how do you train people flying the drone and capturing the photographs, videographs, and processing and putting it. So that will be also one of your, I would say, entrepreneurial skills,
Skill.
teaching skills kind of thing. Like, as you said, you want to learn, let's say, thermal. So try to find out if you can find out somebody who teaches this. But at least I have not encountered anybody who teaches this kind of skills as of now. People have learned on their own as of now. So think
But
about something. You can have your own thermal this thing, and you can start. I mean, DJI has the drone also, which has this capability.
यावरती एक प्रश्न आहे मला की मी जर ड्रोन पायलट आता हो झालो
Hmm.
की त्यानंतर मी ह्या पद्धतीचे ह्या कॅमेरावाले ह्या लेन्सेस वाले मी पेलोड्स वाले गोष्टी फ्लाय करू शकतो का म्हणजे
Oh. Yes, yes.
इलिगल आहे म्हणजे
See, payload is one thing. It is an application of that particular drone. Like, let's say you are now a small class pilot. So whatever drone falls in a small class, you can fly, irrespective of
एनिथिंग
irrespective of for what purpose it is used.
ओके ओके
It is not illegal. Okay,
ओके
whatever you are doing in a capacity is with the authority and approval. Like, if you are using RGB camera to capture images of XYZ location, you are authorized and have a proper approval to do that. You have a thermal camera, you have a proper. Let's say tomorrow you have a DJI camera which is having a thermal payload, और आपको कोई प्रोजेक्ट मिलता है to do the surveillance for the solar panels, you can do that.
ओके
Or you can take that drone on a lease also. Like, there are people who are leasing this type of drone. So तुम्हारे पास अगर कोई project आता है, you can take a call on that. Whatever, let's say that guy is leasing you that drone for, let's say, for a day at 10,000 rupees. Example दे रहा हूँ. I am not sure about exact amount, but let's example वो 10,000 तुमको charge करता है 24 hours का. So what you can do is, you can always quote the outside person, like, okay, I will do this based on the requirement. He said, I want all my solar panels to be imaged using the infrared camera or the thermal camera, for example. So you said, yes, I can, because you are already well versed with the flying of the drone. The way you are flying for RGB, same way you have to fly it for the thermal. You capture all the images, you get the thermal images, and then you share it back to the customer, and you charge him 10,000 plus your charges of flying skills. Let's say 20,000 आपने charge किया, you will get 10,000 your service charge, 10,000 you pay back to the person who has given you the drone on lease. That's how you can make money. Not necessarily every time you have to have the device or have to have a product in hand, right? Or
ओके
you can purchase the drone and then you can take more projects on it, like the way you are doing now for your RGB activities,
थँक्यू
right? Jagan, any questions from your end on payloads?
Uh, uh, I was thinking, I mean, other than the cameras, so if even if I do the delivery, so there'll be some mechanism to drop and hold the parcel, right?
Yeah, yeah,
Something
yeah,
like that.
yeah, yeah, yeah.
So that also includes in a payload.
Yes.
Anything other than
Oh,
the
if you see the
drone.
delivery drones, they have a mechanism where it is little bit what we call that as uh, relays, because there are relays,
ट्रिगर रिलीज ट्रिगर
relay trigger kind of thing. Okay, so it will go down that box, it will clamp it. So it will have that relay in that. So it will clamp that box to the drone, and then it will fly. The moment it reaches the destination, it will go down, it will land, it will release the clamp, and it will fly back. Something like that.
Okay. Okay.
Some places you may not have that facility. So like I have seen a drone for a medical supply. You physically there is a casing made below the drone. You physically put the, let's say, a blood this thing, blood bank packet into that, and you pack it, and you say, then you fly the drone. It will go to the destination. It will land. The person has to come near to the drone, because at one time the drone would be shut down. Okay.
With a fixed container.
Fixed container. So then the person has to come. He has to pull out that the blood packets and all that things, and then he might call the vendor that I have taken the thing. You can trigger your drone to fly back.
Okay.
Or there might be automation that for 10 minutes it will shut down. You will take down by that time, and by the after 10 minutes it will again trigger on its own, power it on, and then it goes back to its destination. I think I had, what was that? Drone.
Yesterday I saw one video. It's like DJ's fly cart something.
Uh-huh.
So it was carrying 100 kg something.
Uh-huh. See, there are lot. I mean, whatever we see, there are much bigger projects are going on, and you do not know how drastically this entire industry will change. Uh, this is a video on the YouTube.
So one qualification which is quite popular in FP&A, financial.
काहीतरी ग्लिच झालाय. पूर्ण रिस्टार्ट करा.
Since we started operating our first system in Rwanda more than a year ago now, we've been designing our next generation system from the ground up, incorporating all that experience.
Here you have to
Here you
physically put the package
So we've had to redesign pretty much everything about the plane
and then this is
our
a
systems
catapult
to support scaled operations. So instead of being able to do 50 flights a day, we want to be able to do 500 flights a day from a single distribution center. We pull the blood or the medical product for that order, put it in a package, put that package into a zip, and launch that zip. The aircraft weighs 20 kilograms, about 45 pounds.
these steamers and also easy penguin to
It has about 10-foot wingspan, 3 meters, and it can carry about 3 pounds, 1.75 kilograms.
हे एअर ड्रॉप सारखं आहे ना, म्हणजे
Speed and direction. And so if the wind's blowing in a particular direction, it's going to compensate and drop that package so it lands on the ground right where you want it. We can hit an area about the size of 2 parking spots. It looks like kind of like a cake box with a paper parachute on top. A fixed-wing aircraft can fly dramatically farther than something like a quadcopter.
how the
How the
so
You saw how it is written back and it is captured through the teeter line, right?
Yes, yes.
Parking spots.
It
It
returns
looks
back.
like a kind of like a cake box with a paper parachute on top. A fixed-wing aircraft can fly dramatically farther than something like a quadcopter, and that's really important.
फायटर जेट जसे याच्यावरती कॅरियर वरती हे केले जातात.
Approaches to things like safety are also much easier. On our aircraft, for example,
How it opens that fuselage, you
the
saw that?
plane, if either one of those stops working, the plane flies just fine. We're in Rwanda today, and we're expanding to cover the other half of Rwanda as we speak.
Almost
And then
500 flights per day they are doing.
from there, we are really focused on solving this problem, access to medical products at a global scale. There's access to medical product problems in the US and in the developing world, and we really want to solve all of those problems everywhere.
Again, this is also one of the
सोचो आप किसी पहाड़ में किसी रिजॉर्ट में चाय की चुस्की ले रहे हो और अपने लैपटॉप पर अपनी वीडियोस एडिट कर running in all of these countries. And while they serve 3,000 hospitals globally today, that number will be 10,000 by the end of the year. All right, so we've covered their long-range country delivery drones, which means we've now got the context to talk about their short-range city delivery drones. But first, I just have to interject here and say I was blown away by Rwanda as a country. I mean, right out of the gate, their stoplights are really cool because they're just countdowns till the light turns green. They can balance and carry pretty much anything on their heads. And there's motorcycle taxis everywhere. And given that win in Rwanda, you do as the Rwandans do. Whenever possible, that's how we got around ourselves. Everyone was also super friendly everywhere we went. Well, not everyone. Because that was them in the air. Everyone was living with the purpose everywhere we only exist in these two tiny
actually delivering medical supplies, especially in the areas of Africa's, like Kenya, Congo locations. I have one video which gives you the application of drones.
ते जे ड्रोन परत त्यांनी थांबवला गेला तर ते आपलं एअरक्राफ्ट कॅरियर असतं ना त्यावर कसं ते थांबवलं जातं
Yes, yes, yes.
तसं ती टेक्नॉलॉजी आणि हे एअर ड्रॉपच होतं म्हणजे ते ड्रोनने केलं ते.
Correct, correct. We can look for there is Amazon.
आता ड्रोनने
Amazon first touted its then futuristic idea of delivering packages by drone a decade ago. The company now officially has begun package deliveries using drones. It's to customers in Arizona, and that is where we find Kate Rooney. She's in Phoenix. Kate.
Hey David, yeah, so Amazon has been testing these drones across the country really for years, but they officially went live here in Phoenix about a month ago. Amazon is now using drones to deliver packages around the Phoenix metro area. These aircrafts are meant for smaller items, so think of things that would fit in a shoebox, for example. They weigh less than 5 pounds or less. We saw the example we saw here that was delivered was a Jenga game. You do pay about 10 extra bucks for drone delivery to get it faster. You do also have to confirm where you want it dropped off on a map of your property, so you kind of have to set it up. There have been some drastic design changes as well over the years that cut the noise of these recent aircraft by about 40%. They can now go roughly double the distance. Also, through testing, figured out things like dogs. Some dogs like to chase drones, you can imagine. They changed some of the design. I did get to sit down with Amazon executive David Carbon, who spent nearly a decade at Boeing. He tells me managing airspace has been the biggest challenge and does see drones as a supplement to Amazon's truck drivers.
At the end of the day, we're going to need every facet of delivery that we can get our hands on. There's not enough people on earth to deliver how much people are going to order. So I don't see this impacting that at all. This is about speed. It's not about anything else. It's about safety and speed.
Amazon got FAA approval for its MK30 drones back in October. This drone site where we are here is integrated directly with the same-day fulfillment center, which is how Amazon plans to scale this program.
This is just a
This is just a 1 month time video.
Next year, the goal, they say, 500 million deliveries a year.
Even this
zip line also. There is
there is a wire
which comes down.
comes
This
down.
year, there will be over 5 billion instant deliveries from on-demand apps in the US. And that doesn't include the billions of packages sent by FedEx, UPS, and Amazon. Every one of these deliveries relies on infrastructure that's 100 years old. It's slow, expensive, and terrible for the environment. It wasn't built to keep up with today's demand. With a better system in place, one that's actually built for the 21st century, we believe the demand for delivery will grow by another 100x and transform the businesses that capitalize on this shift. But we don't have 100 times more humans to drive cars all day. Our roads can't handle 100 times more traffic. And the last thing our planet needs is 100 times more pollution. Automation and zero-emission vehicles are the answer. That's why we built Platform 2, to fully automate home delivery. These zero-emission aircraft are 10 times faster and significantly less expensive than traditional delivery that uses a 4,000-pound gas combustion car. And we're investing in all the auxiliary software, ground systems, and infrastructure that will enable Zipline to make millions of deliveries a day. Soon, everyone will be able to use this new service to get instant delivery of medicine, groceries, wellness essentials, dinner for the whole family, and more, teleported directly to your home in minutes. Our team has 10 years of experience making more than 1 million commercial autonomous deliveries and flying more than 80 million autonomous miles. We've learned along the way and bring a lot of real-world experience to this specific challenge. Zipline is building the first logistics system that serves all people equally, enabled by cutting-edge powertrain AI.
We'll be making instant deliveries for partners
I'm
all
just
over
I'm just
moving
forward.
for loading, using either an indoor or an outdoor loading portal. It takes just a few seconds to load and send the order. The system then does automatic safety checks before the droid goes back into the zip, and then the zip takes off. At the delivery location, the zip stays high in the sky, safely and quietly out of the way. The droid descends from the zip on a tether and self-navigates to its precise delivery spot. The droid then gently delivers the package and turns back up into the zip. The delivery itself takes just a few moments, and then the zip is back on its way to a dock to charge. It's all pretty mind-blowing when you see it in person, but eventually you think it's going to be normal, boring, everyday delivery, only much faster and better for the environment. To get there, this technology has to be as reliable as humanly and robotically possible. So, over the past year, we've been putting our hardware and our software through rigorous around-the-clock testing. Right now, we're doing thousands of tests every day on each and every component. Cycle testing on our roll tilt, motor spin testing in our wind cannon, wingtip light function testing, grid door testing, vibration and pogo testing on our primary structures, and so much more. To prepare for both icing conditions and extreme heat, we run thermal chamber tests from -50 to 170 degrees Fahrenheit. And we're also doing full flight testing in cold Wyoming winters and hot California summers. We're also running millions of simulations for every scenario our zips might encounter in the skies, no matter how unlikely. We push our zips way past their limits, so we know where their limits are. This testing helps us ensure our aircraft are safe and reliable before ever flying in your community. Even the smallest screw has been put through hundreds of tests to ensure performance and dependability. And if we make a change to a certain part of our drone, we test everything all over again until we're absolutely confident it's safe and reliable to do tens of thousands of flights. We've taken the same rigorous approach to working with our partners, iterating side by side with our early adopters to make sure we've built something that's just as easy to use for our businesses as it is for their customers.
Hi, I'm Donovan. I'm here at the aviary, Zipline's headquarters in South San Francisco. This is where hundreds of our teammates come together to build the technology behind the world's largest autonomous delivery service. One of my favorite things about working at Zipline is that we have so many types of experts here, from aviation to autonomy, mechanical engineering, customer experience design. It also means we get to see some really cool stuff each day. Let's go take a look. In true Zipline spirit, we make use of all the space we have. This is where we do droid delivery testing to make sure we can avoid obstacles and deliver as precisely as possible. This is an early prototype of one of our docking stations. It's where Zips dock in charge while operations teams load packages. As you can see, it's currently folded down, which makes it easy to do maintenance. You've seen the docking station. Now let's go inside to see the loading portal. When our network of Zips serve a particular region, they automatically shift around the area based on demand. That means in the morning, the Zip may be delivering donuts for the office, then move to a salad shop for the lunch rush, and finish its day delivering allergy medicine from the grocery store. After a business signs up, we have easy-to-use loading portals so they can send deliveries. The portals can be inside, outside, or even on the roof. We customize installations based on the building and how much delivery capacity is needed. Once it's set up, businesses can choose to take orders via the Zipline app, offer Zipline as a delivery option for orders placed on their own site, or both. We also take extra precautions for healthcare deliveries. We use a dedicated fleet of Zips for transporting medical supplies, and we don't collect sensitive healthcare data. No matter the type of order, they're loaded into the droid in a matter of seconds. The droids fit a lot. Dinner for the whole family, or that grocery list that feels like too much to go without, but not enough to pile the kids into the car for a trip to the store. To ensure we're a welcome addition to any community, we focused on making our technology fast, safe, quiet, and easy to use. No matter the industry, our service is built to delight customers.
I'm really excited to show you what it looks like when a droid comes and delivers in your yard. We think this delivery experience is just absolutely magical. A big part of magical is being quiet. What's that sound? Are you mowing your lawn? There you go, put it off! Thank you! So right now the Zip is way overhead, and the droid is coming in to make a delivery right behind me, and you barely even hear it. There it is, the door's open. It had a package it would have left it, and there it is. That's the whole delivery experience.
You may know Zipline's technology, the lives we've saved all over the world, or the wow factor of our delivery. But what you might not know is that we're also manufacturing in the United States. I'm Kevin Malloy, Head of Material Planning and Manufacturing Operations at Zipline. Let me show you where we've been manufacturing droids, and every single Zip starts here, at a facility that was built from the ground up to ensure that we deliver on our mission. We manufacture close to our design, reliability tests, and operations engineering teams, so that we get a steady feedback loop between what we design, what we learn from testing, and what we make. We've built business information systems that allow us to track components that go through inspect and test the quality and safety of the design for our docks on the line and easily access the top and bottom of the structure. Or this arm to safely place the Zip in a box for pack out and ship. Zipline leans on proven manufacturing operations day in and day out. But more importantly, much like Zipline as a whole, our entire manufacturing system is innovative, efficient, and above all else safe. We keep this in mind today as we are ramping. Automated delivery marks a major shift in logistics. 10 times faster, zero emission, dramatically less expensive. Our mission is to approximate teleportation. Anyone on Earth should be able to press a button on their phone and get what they need just a few minutes later, no matter where they live. Zipline's home delivery service will feel that magical. We're going to make delivery feel like the internet, instantaneous and universally accessible. We'll get cars off the road, improve air quality, expand access to healthcare, and free up time for busy families. In 10 years, people will wonder how the world ever waited 2 days, even 2 hours, to receive deliveries. Or how it made sense to order a private taxi for your burrito. Or that you need a car at all in order to access basic necessities like food or medicine. Once people experience the magic of the delivery service that feels like teleportation, there's no way they're going to be willing to go back to old, slow, inconvenient systems of the past. Thanks for believing in us. and supporting our mission. Automated delivery is the future of logistics, and we're excited for you to experience it firsthand.
So you see how, I mean, we are not near to this, what the thought process these people are talking about. Okay, the drone deliveries or even the drone taxis, what they're talking about. So at the end, that person spoke like in next 5 to 10 years, you will actually imagine how did we were passing the time waiting for our product what we ordered to be delivered for 2 days or 4 days or sometimes even 5 6 days kind of thing. Here we are talking about a matter of delivery within timelines like 10 minutes to half an hour or max, within that less amount of time. That's the speed at what the things will move on, and I think we had a lot of India needs to do a lot of catching to reach that speed of delivery using the drones. Okay, so today we are at the. You want to take a break, 5 minutes or 10 minutes before we begin?
It's 4-5.
Hmm. 4 5. I think we spent time 15 minutes in our video. So let's take 5 minutes break or 10 minutes break. 4:15 will start.
Yeah,
Okay.
sure.
We have the last topic, drone data and analysis to cover up. Okay.
Okay, Mangesh.